Hello, everyone. Welcome to Wednesday, September 16th. It is National Play-Doh Day today, just in case you were wondering. But today was a good day. What we did, uh, we did a little dimensional analysis, and I'm going to write this a little activity, and I'm just going to write the steps down. I'm not collecting it, but it's just something you can do. That was interesting, I felt like. And then we did a little bit of scientific notation. We did a little walk around. And as you might have noticed, I did post that in the classwork tab uh, so that you guys can try it out and practice. Okay. So first, what we did was we did the dimensional analysis activity. So this is what it looked like. Okay, so this is step one. Step one says measure an object using an object other than a ruler. All right, so my example was I measured the length of a table using markers. Okay, and the markers was I had 21.1 markers equal the length of one table. Okay, so that was my example. Step two, I want you to measure the measuring device. Measure the measuring device. Okay, it's a little unique. Okay, and in my example, I had one marker was about 12 centimeters long. Okay, I measured in centimeters. Okay, step three was dimensional analysis. All right, dimensional analysis to see how well we did. Okay, now in my example, I wanted to see how long one table was. So when I'm doing it, I'm going to make my railroad tracks. So one table is a total of 21.1 markers. And I have table on top. I'm going to have table on the bottom. So those two cancel. Okay. And then I'm going to have marker on the bottom. One marker equals 12 centimeters. So my markers cancel with my markers. And all I have to do is solve because all I'm left with is centimeters. So if I plug this in my calculator, I get 253.2 centimeters. Okay, so that's my answer. Now, I actually measured the length of the table, and the table is actually 243 centimeters. Okay, so step four, measure what you measured at first. So measure what you measured first with a ruler. With a ruler. Okay, so that's step four. Like I said, mine was 243 centimeters. That was the length of the table. All right. And the final thing I want you to do is calculate the percent error. Okay. That's a new equation that we're going to introduce in here. Okay. So percent error is equal to the absolute value of the theoretical minus experimental. Close my absolute value. Divided by the theoretical times 100. So there's our equation. There's our equation. Okay. So my theoretical was 243 243 minus experimental. My experimental value was 253. That was my guess. Close my absolute value over 243 times 100. Okay. Oh, can barely see the bottom. There we go. So I'm going to plug this in my calculator real quick. 243 minus 253.2. So my percent error was 4.20%. So that's 4.20%. I feel like that's pretty solid work. It's not too bad, right? 4.20%. It's pretty good. Okay, so that's what we did. That's what we started off with. We did a little dimensional analysis. Okay, and then we went into scientific notation. Okay, and I'm going to give you guys some examples of scientific notation. I know you have seen this before, but it's just good review to start chapter 1, or start chapter 2, which we're actually starting tomorrow. Okay, so if you see a number like 0.000022. Okay? Remember, in scientific notation, you have to have a number between 1 and 10. Okay? Between 1 and 10. So when I move my decimal over 1, 2, 3, 4, I'm going to move it right there. So 2.2 is between 1 and 10. Okay? So 2.2 times 10 to the 1, 2, 3, 4, 5. Now, when you're moving to the right, it's negative. Okay? When you're moving to the left, it's positive. So that would be my answer. Okay? Let's give an example, 76,000. Okay? Secretly, my decimal is right there, right? So I'm going to move it 1, 2, 3, 4. So I have 7.6 times 10 to the 4th power. And that's your answer. Okay? That is a little review of scientific notation. Okay? Now, I did post the walk around. When I posted it, the answers are, I think, in order. So don't look at the next page before trying it. Try some of these problems out. Do you have to do all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14? No. I want you guys to get enough practice using scientific notation and significant figures. Okay? Make sure your significant figures are correct. But if you have any questions, let me know. I look forward to doing tomorrow, starting chapter 2. We're going to be talking about kinematics, and we're going to hit the ground running. Hope you guys are ready. All right, we'll see you tomorrow.